Thank you very much, and welcome to the panel number 3 or 4. Next stop, the moon and beyond. And so we have heard quite and discussed already a lot about the moon, also just in the recent talk. And we have also seen that we are really standing on the threshold of a new era of space exploration. According to Tech, which has made a statistical analysis, there are 150 missions to the moon planned to cislunar regions as well as to the surface of the moon until 2034. So probably not all of them will make it, but this is quite a testimony, 150 missions in the next 10 years. So with this renewed missions to the moon, we are also laying, of course, the groundwork for long-term exploration, scientific discovery, and sustainable presence beyond Earth, and of course also going to Mars and further on. The moon serves not only as a proving ground for advanced technologies and science, of course, but also as a gateway further into the solar system. So international cooperation, we heard a lot about it at this conference. Also commercial innovation, and we had great panels stating what is the progress there. And of course, scientific ambitions are all converging, to drive this new chapter in space exploration. And I think it's also important from the science point of view, and why? Because everything is going so fast and there are so many missions going to the moon, that we should not forget that moon is actually a part of the Earth. And exploring the moon provides really also crucial insights into the origin of our solar system, the formation of our planet Earth, and also the roots of our own existence. So I want to welcome really our distinguished experts from Space Agency and industry on stage. Dr. Daniel Neuschwander, Director of Human and Robotic Exploration, European Space Agency. I was wondering where the music was, yeah. Mr. Kazuyoshi Kawasaki, Deputy Director General for Human Spaceflight and Exploration, JAXA. Professor Anatoly Petrukovich, Space Research Institute, IKI. He's the director. Mrs. Naiga Shaji, Indian Space Research Organization. She is the Assistant Director of the U-RAO Satellite Center. Welcome. Mr. Pierre-Alexis Chumel from Airbus Space and Defense. He's the Director for International and New Business. And Mr. Vincenzo Giorgio from Thales Alenia Space Italy. He's the Vice President for Institutional Marketing and Sales. So this is a very nice distinguished panels, and I just want to say for the logistics, we have some of our participants which do have slides, and here is the clicker. And since we are speaking in the way here, this is the clicker for eventually your slides. And so I just want to start off by thanking, the participants from all the parts of the world to be here and to discuss this really focus and renewed interest on moon, but also, being a test bed for the future, going further into the solar system. And so we wanted to start with a lightning round, in particular also from the Space Agency and the industry, in order to discuss what are the current most significant milestones in space exploration in your organization, And we have just heard everything about China, and was a very, very nice lecture to see what their moon program will be. So I start with you, Daniel, and if you press, luckily there should be your slides.
Thank you very much, Pascal. Good afternoon to all of you. This session is about the moon, but I would like to underline first, number one, that we cannot see the moon in isolation. We see from ESA it as in synergy with low Earth orbit, moon and Mars together, number one. Number two, you see here a slide which was presented by our Director General yesterday at the opening, and there is one key takeaway. You see a lot of flags here. Exploration is about cooperation. And from the European side, what really matters is at ESA, we want to be a reliable partner. This is a mandate we have from our member states. And number two, we also want to see additional flags. We think for exploration, it is a common endeavor, and we want to do it together. Last element, what is not on here is that the technologies and scientific elements need to prepare at all destinations in a synergetic way. And of course, you want to de-risk yourself as close as possible from your home. So this is why we start on Earth with analogs on ground, then go to low Earth orbit to then continue towards the moon. The next element as a milestone is that we have astronauts, and to fly our astronauts is a fundamental element. You see here part of the European ESA astronaut corps. This is a new class of which was promoted in 2022. And all these young people deserve flight opportunities. Flight opportunities are important, of course, first also here to low Earth orbit, second then to the moon. We have in our existing astronaut corps also more senior astronauts who have all flown to the International Space Station and who are definitely ready and qualified for the next step and next stop, which is the moon. Last and third slide is that there are key milestones at every destination. We consider at ESA that transportation is fundamental. Before we go to the destination, you must have your own transportation means. Our member states took a decision in Sevilla 2 years ago to go first to a LEO cargo return service. And this LEO cargo return service is the pillar of the transportation capability that we have to implement our exploration program. And what is important is that this project has two key requirements. It shall have the possibility, if the political decision is taken, to evolve towards a crew transportation vehicle. Number two, it shall have the possibility, if the political decision is taken, to bring back also samples from the moon. This brings us to the moon. Second key milestone is the Argonaut Mission 1. From the European side, a number of partners here in the room have shown their landing capabilities. Today, we use partner landers to get to the surface of the moon. We would like to develop our own capability. The project has a name. It's called Argonaut. We are going for Argonaut Mission 1 at the beginning of the next decade. And this will just be the starting point, a starting point to deploy surface capabilities, a starting point to really bring Europeans first in a robotic and second also in a human way to the surface of the moon. And last but not least, the session was called Moon and Beyond. So let me just mention here again that we have on Mars also a whole program. I will not dig into it, but the next milestone is Rosalind Franklin, and we plan to launch it in 2028.
Wonderful, thank you. An ambitious program, and we will then, I think, have some questions about the future in general also. And I continue with JAXA and looking at the current milestones of JAXA.
Thank you very much. As Mr. Daniel said, we are all thinking about this moon development following IS program. That is the expansion of the human presence for the vicinity of the moon. And we also have the Mars mission for the scientific objective. But today I will talk about the key milestone for the moon development. And this chart shows the two missions. Left-hand side is SLIM. We have already successful pinpoint landing on the moon last January. It's a mare of what can name Nectaris area. And the picture was, SLIM was a little bit tilted, but still, they are still alive, and we think achieved that pinpoint landing so successfully within the 10-meter accuracy. And we took that picture from the small, tiny robot. It's a Suraku. It's another collaboration with industry, non-space industry, that is a toy maker in Japan. And it's only 300 gram and 10 centimeter diameter, and like a baseball sized. They can take a picture and send back to this data from the moon. So we can prove that a so small robot can achieve this kind of mission. And we also have shown that collaboration with non-industry partners is very useful to do that, to take a picture. Yeah, I think that's some kind of historical pictures, I think. And the next key milestone is LUPEX, lunar polar exploration in cooperation with India. That we have a lot of discussion today at another room, and we have a lot of questions about this mission. And we are looking for that water existence in the moon south polar region. India is the first country successfully landed to the South Pole. So we are looking forward to collaborate with the LUPEX mission. Another word is that Chandrayaan-5 mission. And we will provide this rover, but India will provide us that lander. And also JAXA provide the H3 rocket for launch this mission. So after this mission, we will determine the amount and possibility of the existence of the moon, water, ice on the moon, and expand our human existence on the moon using water. So we are now studying that how to expand that region for the searching area. So we are planning to provide another non-space industry cooperation with Toyota. It's a pressurized rover is a very key element for the Artemis program. We are targeting it launch in 2031 and will be operated about 10 years. And 1 month per year is manned operation, and another 11 months is operated by automatically. That is our planning to that. That is status.
I just have a very short follow-up question. The timeline for this pressurized rover is?
2031.
2031. Very interesting. Thank you very much. We continue with Iki Srasha.
Good afternoon, dear colleagues. I would like to thank organizers and the hosts for this wonderful conference. And there will be presentation. Okay. Okay, and let me first say a few words about my institution. We are the leading Russian academic institution for fundamental and applied space research and exploration. We do all kinds of fundamental science, astrophysics, solar system, heliophysics, and some theoretical physics. But we also do a lot of space applied studies for space navigation, space instrumentation, Earth remote sensing. Okay, my phrase is in Russian, I am sorry. So today on Earth we have about 1,200 staff, among them only 200 scientists, so we are mostly engineering organization. And in particular we have also the largest Russian archive of remote sensing, about 8 petabytes of data online. And in space we have hardware now working on about 20 Russian and foreign satellites. Speaking about exploration, during last 20 years, we had very successful collaboration program with Russian instruments on foreign spacecraft, and the one main results related to exploration are water ice maps for Moon and Mars, which were calculated based on neutron flux attenuation in the ice. And currently, we have in flight two space science missions. One is X-ray Observatory since 2019, 6 years of successful operation in space. And previous year, we launched 2 atmospheric spacecraft for space weather studies, and 2 will follow this year. Concerning lunar program, unfortunately, Luna 25 was an unsuccessful landing in 2023, and we are planning next missions in the next years. I'm speaking carefully because right this month, the government, Russian government, approves the program for next 10 years. And so I think it will be announced officially a little bit later. And besides that, we have selected instruments on China 7 and China 8. And China 7 flight model is already delivered. It is dust counter. Dust is very important part of lunar exosphere, which will definitely affect any permanent operations on the moon. And speaking about more distant future, we, as an academic institution, offer to Russian space industry an extensive science support for exploration program, for new space station science, and for long-term projects and goals like nuclear propulsion and outer planets and human spaceflight in deep space. Finalizing, this year we have 60th anniversary of our institute, and the last but not the least, to promote this space exploration, we have among public in Russia, we have a vast outreach program. We have a museum of space science and technology, and we have about several thousand visitors per year, mostly school children. Thank you.
Thank you. Congratulations for your 60th anniversary. We continue with Israel and Mrs. Nigar Shaikh.
Thank you for the opportunity and nice to be here. And Indian Space Research Organization tailored the space program on 2 goals. One is to benefit the countryman through space technology, and then next is to inspire and motivate the younger generation of the country. And we have our 2 parallel programs. One is the lunar exploration, and the other is the human space flight. India's foray into lunar exploration started in 2008 with the orbiter around the moon, and followed by that we had the landing on the moon, our Chandrayaan-2 and Chandrayaan-3. And we have a host of missions lined up, culminating in landing on the moon by 2040. And the series of missions are planned such a way so that each mission with technological and scientific objectives, which ensures a steady progression in complexity and capability. So we have next a sample return mission, followed by establishing a communication navigation network around the moon for our further lunar missions. And we have finally, by 2040, we will have a crewed landing mission on the moon. And throughout the series of the missions, we'll have the payloads, which can do experiments on in situ resource utilization and in-space manufacturing, plant growth, and radiation and temperature profiling instruments, so that it will help us to, further from 2040, we'll have all the necessary inputs for having a habitat on the moon. And the next is we have the human flight program. As you all be hearing from since yesterday, the Gaganyaan program, and we have many follow-on missions on Gaganyaan. So finally, we will be building 5-stage space station, and by 2035, and we'll have the first module by 2028. And these missions and the experience what we get on the microgravity experiments and the psychological and physiological aspects of the crew, that will help us in having the crewed mission to moon. And interleaving these 2 parallel programs, we have Mars lander, so have acquired the expertise on landing in a planet with an atmosphere. And also we have an orbiter around Venus, and also we have an exoplanet mission to study the atmosphere of the exoplanets And this is how we planned our space exploration program. Thank you.
Thank you. And because of this really interesting program, we are also all here in order to understand and to cooperate. I come to the two industry representatives, and I start with you, Pierre-Alexis, Airbus, and your milestones in your company, contributing to this new space exploration era.
Thank you. Thank you, Pascal. I would like to thank also the IF for the opportunity to speak. So yes, indeed, at Airbus, we are involved in different destinations. I will start from low Earth orbit to the moon. On low Earth orbit, we are, of course, involved in the ISS. We contributed with the Columbus module that we are still doing the operation until today, and the many payloads that we've done for our national space agency. And now we are also engaging in parallel into the next generation of commercial space station. I think there was a panel, very interesting panel this morning, moderated by Clay. We are supporting the team of the Starlab. And this is also an approach very international, very global, because this concept is supported by a US company with Voyager, Airbus in Europe, Japanese company with Mitsubishi, and in Canada with MDA. So international collaboration is, I think, the main topic of the conference, and that's what we are also recreating with this next generation of commercial space station. Now, going into the moon, we are engaged together with our partner of Thales and Ariane into the Artemis program. We are working on the European service module, which is the service module attached to the Orion capsule. We have delivered 3 modules right now, and this is also based on international collaboration between here the US and Europe. And now talking directly, mostly on the moon surface, we are also developing technologies at Airbus about how to use the lunar regolith, how to extract pure oxygen, metal from this regolith, and how we can use it. We are also working on a 3D metallic printer that we are testing right now on the ISS in microgravity in order to be able to use this kind of resources that we will find on the surface for a sustainable exploration on the moon. So right now we are really focusing on delivering those missions to our customers. That's really our priority. But in parallel of that, we are also adapting to the moving environment and diversifying the different partnership we have all over the world. And that's why I'm very pleased to be in India, to see the ambitious program and the strong leadership they have in space exploration. Thank you, Pascal.
Thank you very much. I think it's very important that we have a panel with space agency and industry showing, how the new area will be, and that there will be really a multi-stakeholder approach, and there are many more stakeholders out there, and that we all work together to make all these discoveries and these new missions working. So as a last speaker for more or less the introduction, this is for Vincenzo, and milestones of Thales, apart from ExoMars, of course.
Yeah, which is one important. Okay, first, thanks for being part of this fantastic panel. Actually, I will start saying that I would like to share what Daniel said before about the vision of exploration not being just a piece, low Earth orbit, lunar surface, and Mars, but it's one real experience that as industry we are having, bringing the experience on one to the other. We have had a major role in the manufacturing of the habitable volume of the International Space Station. It was said more than 40% of it has been built by the company, and we are having a significant role on what is going to be the lunar missions, both on orbit, together with ESA, but also with the international partners like MBRSC, and we are delivering to US company important pieces. Also on the surface, as our National Space Agency is planning to send the first habitable volume on the surface of the moon. And this going to Mars, you mentioned ExoMars, we have to remember that we still have a TGO since 2016 orbiting around Mars and performing perfectly as planned. And we are going also to approach the Rosalind mission in 2028, which actually was ready in 2022, but we had to delay for, let's say, political reasons. What I have to say in addition to the programs is that we share the fact that, first of all, Daniel said, we have to be a reliable partner. We say we have to be a reliable industry in delivering, in quality, cost, and schedule. And that's what we are trying to do, and I guess that's the key success of the industry, which allowed us also to play a role into the commercial LEO development. We are talking with most of the actors of this commercial LEO development in low Earth orbit. For some of them, we have already even built the flight models of the modules that will very likely fly. So everything comes from the fact that we acknowledge the fact that we are part of a puzzle, and we develop technology. Our agency is making the strategy, and we are able to use our technology not only for the agency, but also for different missions and programs. So therefore, this leads to the conclusion that those kind of mission, those kind of adventures, I would say, are mandatorily done by international cooperation. You cannot do it alone, whoever is in whatever country.
Thank you very much. So this was more or less the introductory round, and now, come the hard questions. I want really to activate everybody in the audience. I have already some questions, but please use Slido to ask your question. It's a one-time opportunity, all the space agencies and also industries to ask questions. And I'm just taking the first one which came in, because it was also the first one which I was supposed to ask you anyway. And that is, what are the key technological challenges that must be addressed for a human landing on the moon? And I think that is always a really big step. Of course, we have done it before, but in very different circumstances. And I think it is still a really, really big step. So who would like to answer some of this?
May I start, maybe? Okay. First, I think what is really important is that we see it segment by segment. One element is the transportation, and it's also an opportunity for us to recall that from the European Space Agency. We provide the European Service Module to Orion, and today no US astronaut is flying back to the moon without the European propulsion system. So first you need to get there, you need to get to the moon. Second element, and it was on the slide as well, is gateway. You need to be able to stay at least first in orbit. Let's not forget, let's take it step by step in an incremental way. We are today partner of Gateway with fundamental aspects. I would like to highlight here also the ability to secure crew safety. If you say crew safety, and if you follow our path of saying we want responsible exploration, you also need to develop countermeasures. This means that first we also need to characterize and understand the environment, and radiation is a fundamental aspect here. We're having today fundamental experiments and instrumentation on radiation, because crew will be exposed to a different environment than what they have in low Earth orbit, especially for long duration mission. And then the third element is, of course, to get to the surface of the moon. There, I think there are two aspects. One is, again, the transportation element, which, as we know, we need to do a small delta development in order to really have landing capabilities. And from the European side, we certainly want to support and be part of such an endeavor, but we consider this in a partnership, definitely. And second, once you reach the surface, you need to be able to stay there also in a safe way. And this will certainly start also by collaborative aspects of robotics and human capabilities working hand in hand. And here, I think that Europe can bring some specific capabilities when it comes to this interaction human-machine interfaces. And we have some ideas which we will put forward also for decision to our member states at the end of the year.
Anybody else? I got a really large number of questions, I just tell you here. Please be short.
Okay, what I feel, it's not only Moon and this Mars, but for the long stay, the psychological aspects of the humankind. The crew, what is going to be there, it's much more important, and they have to be trained and to be there, because the human, always we wanted to live in company and in this restricted quarters with the cohabitation and the need for love and belonging. So that aspect to be dealt with in a better way. For Mars, it's much more important, and we have to be very far and for months together. So I think that's the most important aspect which need to be looked into while go for a space, having a habitation in the multi-planet when we want to become a multi-planet species. I feel that's more important, because I'm sure that we'll be able to develop all the technologies the way the last decade, whatever the improvements, what we have seen, I'm sure we'll be able to develop the technologies. But this aspect, it needs much more to be looked into. That's what I feel.
Maybe just a quick comment on my side. If we want to stay sustainability on the moon surface, we need also to be able to use the local resources, because we will not be able to bring everything from Earth each time. And here is really something that we are developing in Europe, this technology to extract resources, to develop energy, to develop the telecommunication also around the moon. And I think this is a key contribution to international program, because everybody will need to use telecommunication, needs to use energy, resources, and so on the surface. So.
Yeah, one point very quick is the fact we mentioned about infrastructure, launch, transportation, landing. It was mentioned utilization of resources. Something that we have to be sure on is also to have the ability to operate, to maintain, to ensure the logistics. And I just take the last point, to work hand in hand with the astronauts when building those infrastructure. Just because they are going to live there, we are having experience in our lunar module, just working with the astronauts, we are getting a lot of nice suggestion, which do nothing have to do with the efficiency of the system itself, but the way they are going to use the systems.
Yeah, a lot of challenges, and I think we mentioned only a few. Because if we are going even further into the solar system, it gets even more complicated. I want to say that we have so many questions, so there's a very interested audience, and I'm going to go through them as much as I can, and please just grab the question if you and answer if you want. The next question is technology, if technology permits, which would be more preferable, a fully autonomous moon base or a human settlement?
Just I vote for the human, because we have some. So this moon environment is the first time for the human being. So there's no experience before. So we cannot imagine what kind of happening in the moon surface. So in that case, we cannot use the AI or something robotics mission. I believe that human capability for the human exploration.
Yes, please.
I think the answer to this question might be very different from what we could provide 2 years ago, because last 2 years, 3 years, they had a big burst in robotic, in artificial intelligence, in robotic vehicles, which are moving autonomously and performing operations. So 2 years ago, I would say that human exploration is the most likely and will be most efficient. But now I should say that humans on the moon should fight for their role with robots, because if this boom in these autonomous vehicles will continue, we'll definitely will have fully robotic villages on the moon. And this will be cheaper because robots need not to be returned safely. Yes, that's the main bonus from robots. You don't need to pay for the return flight.
One thing, about 10 years ago, it started a sort of competition between human and robotics, which I think we should avoid to have this kind of scenario. What you have to do, you have to get your results with whatever the means, either human or robotic, and you have to have an efficiency in what you want to get in return of it. I'm still convinced that there are things that human have to do, and there are things that you can do in a robotic way, but it's not a competition between the two.
There's quite a top question suddenly which popped up to two of the panelists. What kind of collaboration can we expect between ESA and ISRO in the near future?
Yeah, we were having talks to how to interleave our program with the Moonlight, because we are also in the plan of establishing a communication navigation network on the moon. And you have a program on Moonlight, and we are on. I think we can cooperate in those aspects of establishing and sharing the communication and navigation network. That's what we are looking into. And also, we are open to cooperation for having payloads in our missions, so that we can jointly have the in situ resource utilization aspects and in-space manufacturing. That's going to be the fundamental for the future habitat building. So I feel I request your comments on that.
Maybe fully shared, Nigar. Maybe just let me add, next to the communication scientific dimension, that also positioning, navigation, and timing is a topic on which we are exchanging on the moon. And we just signed yesterday a cooperation on a joint statement on human space flight. Of course, it will start in low Earth orbit, but I hope that we will go above and beyond low Earth orbit.
Okay, thank you.
Yeah, so our next question is budget cuts, and also that, of course, due to what we experience on Earth, funding agencies might be hesitant about funding space. So how do you see that actually in the future? This is a question which we always get. Why invest in space in difficult conditions? And I think it is important to say, how do you see that, and what are you doing in order to inform society? It has a lot of likes, so I'm asking it.
Yes, okay. In Japan, the government have decided to spend the money to the space exploration. Mm-hmm. It's a strategic fund or something, and the current situation in the industries of space exploration is at a start point. So you need some acceleration money to do that kind of thing. So just starting. So we recognize that the importance of the space industries for future. So we are also trying bringing a new industries like a Toyota or toymaker like that. So bringing this new partners for the space industry. So expanded the economy. So it is a little bit changing right now.
Anybody else? Yeah.
Yeah, from an industry point of view, nobody likes funds to be reduced by definition. Nevertheless, I guess that in the past we have had moment in which the funding was lower than expected, and the result of it was the fact that we were forced, and when I say we, I mean all, agency, industry, and supply chain, we were forced to find solutions to try to meet as much as possible the end objective. And this has resulted in a good technological results. And one example that I want just to bring is when we were somewhat asked to make a very efficient logistic system for the low Earth orbit, we were able to produce something which was cheap and capable, that probably if we would have remained in the past, let's say, scenario, we would not have thought to that.
I must honestly say that we have seen in the panels here in the last, 36 hours, that the space exploration area is really at this threshold. There have never been so many missions, venturing into our solar system. And even if there are budget cuts here and there, this will always happen. It has never been so active, and I think this is what we can all see, and we can just hope, and we have to work for it with good scientific results, with new technologies in order to convince society and everybody how important it is to venture into our solar system, and also to obtain particular scientific results and understand what you can do in the Earth, Moon, Mars space in particular. So I have a question to Isa. 1 second, because they are of course jumping those questions. And as we proceed to the moon and beyond, what about ESA's stance on nuclear power? As right now, ESA does not use nuclear power.
Yes, thanks. I will just take the opportunity to say, here in the room, we all want to do more, there's no doubt. But I think, as we just heard from Japan, I think they took a very interesting initiative with a strategic fund. From a European side, I think we also think about diversification on the sources of the budgets. Number two, if they are constant or decreasing, I mean, we have also to do every effort to reduce the cost of our missions, and we should never stop doing that. And we are here in India. I have to say I'm impressed also with what can be achieved with different types of budgets. Having said that, to go to your question, we have some technology work. Nuclear power is, in our view, fundamental to achieve deep space exploration. You will not avoid to go into this field. We have some concrete technology developments ongoing. We will continue that. And we will also have to be able to launch nuclear-based payloads from European soil. And if we are not giving ourselves these means, I think it will limit the European ambition in exploration. So we definitely want to overcome this.
So there's a question which of course comes always and is important, and I think it is for some technologies which you are all developing important. And this is about the role of AI. What role will it play in the exploration of the moon and all the challenges?
Well, I think AI is a tool for support human activity, and so we are going to use AI for precious rover, so that how to drive the dangerous area. So AI suggests us some candidate which route is suitable, but final decision made by the crew. So I think the AI must be like supporters for the human exploration.
Anybody else? Yeah.
Yeah, okay. Just in the very short time, what we are doing is to use AI for a number of activities. First, to support the engineering and the analysis of the engineering. But the way I see it is that it will be mostly used for all the ground support of the various missions, because maintenance, preventive maintenance, and things like that can be done very efficiently, because you will have always the time then to override in case you need to do it, and you don't leave all this AI playing a critical role in safety on the human spaceflight modules.
I think there will be still a long discussion because AI is evolving as we speak, and it will be really important to implement it into all the autonomous functions. I have one question, which is actually, I think, which answered itself, because we do that already, but it has very many likes. So I'm asking it, apart from technical collaborations on spacecrafts, should agencies not collaborate also on habitability research as well? And I think we actually do that by having international cooperation and instruments on board. But if anybody, since it had such a high number of likes, if anybody wants to say something.
I think that this is a very interesting topic, and this makes our science interdisciplinary, because habitability, we need to understand atmosphere. If you want, for example, autonomous habitats for long-term presence on the moon or on Mars, we need to understand from agricultural point of view what could be grown. And I should remind that all previous large-scale experiments on autonomous habitats on Earth failed after several months because the ecosystem was unstable. And this is a real challenge, and it, I think, could be solved only with some significant collaboration between countries and between different branches of science.
If I may, fully shared food is important, crew health is important, but maybe just to add a thought a bit out of the box, we have also to think what's coming next. If we speak about the multi-destination, multi-planetary species, I mean, we have also to think about long-duration missions. You can ask yourself what it means for the human body. Shall we go towards elements like hibernation, where you have to lower temperature, you have to lower metabolism, you reduce the exposure to on the impact of radiation? I mean, these are so fundamental questions that I think none around here can do it alone. This definitely requires cooperation.
There's a very short question. I think we have seen it on the slides, but I'm just, when will LUPEX mission launch? This is for you too. You will be able to.
No, currently we are discussing about the precise date. JAXA is planning fiscal year 2026. It will be a targeting date. Year.
27, 28 time frame.
So I have so many questions. I'm really sorry, I'm a little bit overloaded. Are aliens there in any planet, and is it proven? I can explain that in the break. Yeah, no, not yet. I think it's not for our panel, but. How actually do we go? I will combine two questions. How do we go about establishing an international cooperation for space missions? Who is actually taking the lead? And then there is also a question if there will be an overarching body which is actually deciding on international cooperation for the space exploration era in the future. It's a bit a complicated question, but I think it would be good that you explain a little bit to the audience how you actually foster international cooperation bilaterally and then actually branch out in order to gain a larger international cooperation. I think for some of the audience, this is not yet quite clear. Everybody has a microphone.
No, normally we'll have what we do in ISRO. I can just explain. See, we have the regular. We have international cooperation office, and we have regular group sessions, and with the NASA and other space agencies, and we'll have fortnightly or a monthly meetings, and there we will discuss our new missions or their new missions and how we can cooperate, and finally we will come to a agreement that what we can do and what they can do, and then it goes to the process of signing the agreement and taking forward. That's how we do it in ISRO.
So a lot of questions I just wanted to say, which are here, are logical. And just to add a part of another question, do you see the current political climate have any drastic effect in missions planned for the coming decade, or do you believe it is robust and shielded? So I know it's a difficult question, but I want to give room, since there are so many questions which are around international cooperation, that everything what's on your chest, please just...
Okay, I can suggest two examples. One example is from 80s, the Interagency Consultative Group, and the first goal of this interagency group, there was NASA, European Space Agency, and Soviet Space Agency. It was the investigation of Comet Halley, when several spacecraft were flying in. And Japanese, I think, spacecraft was there also. And spacecraft were sharing data almost in real time to provide more precise navigation of, finally, I think, European spacecraft which flying almost through the nucleus. It was impossible would be impossible without such. It's very deep cooperation. This Interagency Consultative Group later was also discussing problems of the heliospheric observations, when several spacecraft from several countries were used to combine data and provide the complex view, integrated view on Sun-Earth system. And of course, the International Space Station is a fantastic endeavor, which would be impossible without very deep trust, not only cooperation, but very deep trust between engineering communities of several countries. And I think these are good examples, and it depends on everything on us to continue this, because all space plans are basically set up for decades. And this is much longer time scale, space time scales are much longer than any time scales on the Earth.
So we have, please go ahead.
Just to add what Anatoly said, two other examples. I mean, we have the International Space Station, which is regulated by an intergovernmental agreement, which, of course, has the Russian partner, the Japanese partner, the Canadian partner, the US partner, and the European partner setting a set of rules. Then you have, for example, the Artemis program, where most of our ESA member states signed the Artemis program, which is a different model. And I think the takeaway is there is no one size fits all. Yeah. We have so many exploration ambitions across the world, and I think it's super exciting, super interesting. But you cannot bring there one model. There will be different models, and it will depend on capabilities and also on geopolitics. And these two elements will drive the type of cooperation you will have.
Alexis, I just wanted to add, I will not comment on the political side, but I will take the question from an economical point of view, talking about the economical context as well. When we talk about this large program, talking about a commercial space station or moon exploration base and so on, if you develop a business plan or try to make a business out of it, you need to bring two worlds together. There is the institutional world, which is mostly scientifically driven, with scientific needs and requirements. And you have the commercial world, which is mostly market-driven. And that's the complexity of building a business case, because they have different expectations in terms of financing. When we talk about institutional, it's long-term budget, safe budget. Talking about the commercial world, most of the time the fundraising is still ongoing, so the timeline is a bit different. In terms of IP as well, when we do institutional program, most of the time the IP is given to the industry, because the agencies are made to support industry. When we talk about commercial, the IP is mostly staying at the company, because that's the value of the company necessary to raise the funding. And also how we manage program. When we do program with institutional agencies, for example, there are different phases that we need to follow. When we do commercial program, we can go faster. So we need to be able to address both, because to make a profitable business, you need to address both commercial and institutional market. And that's the difficulty in the current economical context that we have in order to launch this big program. So I just wanted to make this comment on this aspect.
Thank you very much. So we have about 5 minutes left, and I want to go to one complex of questions which came in, and that's sustainability. Yeah, and during moon travel, many debris will be left behind in space, and I guess also on the surface. Are there plans that are currently being developed to clean everything up? And yeah, there's of course also the question of Kessler syndrome in the lunar orbits, which are unstable, and we will have probably faster problems there. So I think if you could just give some opinions to this topic, and then I want just to ask you, a 30-second questions, and then we round it up. Yeah, thank you.
Okay, I would add complexity to this question. The garbage can be collected, but every step on the moon, any trace of any wheel will stay there for billions of years. So we need not only we need also to think how we will move on the moon if we have a permanent, semi-permanent base. Otherwise, in a year, it will be there will be no place for nice picture.
Anybody else on sustainability? It's an important problem. There are many organizations, including the United Nations, which are, trying to be ahead of time, because when we have, as I said, 150 missions planned, in the next 10 years, we actually do have to have some regulations in place or some framework. And
if I may, not sure that only regulations will manage. The question is, are you really taking responsibility? From ESA's side, we have the Zero Debris Charter, and the first place to clean is in front of your house. So in front of our house means first now low Earth orbit. And we have here very clear requirements which we build in any future mission in order to act in a responsible way. For example, just to keep the capability to deorbit your last stage of a launcher, just to start from where we have to start. Then I think on the moon, the intensity of the question increases in an exponential way. And I think we need much more anticipation, but also accept that we reduce some capabilities of a mission in order to secure, to have, for example, sufficient propellant to make sure that you enable sustainability. But that's a choice. That's also, if you think in pure commercial terms, a competitive disadvantage if not everybody plays with the same arms, if I may say so. And last but not least, the less we need to bring there and the more we can do on spot, the more sustainable it will be.
Just maybe to continue what you say, Daniel, I would refer to a comment that the CEO of VAS did this morning in the first panel that I was referring to. There is also, beyond the safety aspect, and the tracking and so on of the debris, there is also an economical impact. There is a cost behind that. And he was explaining this morning that, for example, he has to put his commercial space station in a higher orbit to be more safe than to avoid debris that are a bit lower. And to put a commercial station in a higher orbit has a cost because you have to maintain the orbit. And this was a really interesting comment. We are not thinking about the economical aspect of debris mitigation, but this has an impact on business cases as well.
Okay, I just wanted to comment on, because we can do deorbiting and make sure we can prevent it from crashing onto the moon, but we don't have today's solution for all the landers, rovers, whatever is on the moon, which is to be landed on the moon. And presently, we don't have any solution to clean it and the accumulation of landers and rovers. And as you see, the next decade, we are going to have a lot of landers and rovers by many of our spacefaring nations. So we really need to look into any solution for that. That's an important problem. Orbiting things we can manage. That's what I feel.
Thank you very much. It's an important topic, which I think in particular the young generation is very interested in, and we will hear more about it. There are many working groups, actually, which are trying to find solutions, and it's also no wonder that there are a lot of questions. I think I still have 2 minutes. Where's Christian? 2 minutes. I just wanted that you answer in 10, 20 seconds, maximum 30 seconds. What are you most excited about when it comes to space exploration? 10, 20, 50 years, this is up to you. Just that we understand a little bit what drives you. And maybe I start in the end.
Space exploration. So when presently in the world, many factors are disturbing the peace. I feel space exploration can work in another way to improve the peace of the world and the international cooperation.
In 10 seconds, the power of inspiration that space exploration has on the young generation.
On my side, 2 points. I would like to see even more nations in developing space exploration program. I think everybody should be included in this exploration. And more on a personal point of view is would like to see human going beyond low Earth orbit in the next 20, 30 years.
Okay. As a scientist, I should say that today's space science is totally different from what was 30 years ago when I was a student. And that's thanks to exploration for new technical capabilities. And I hope that what I wait from the future, that in 20 years there will be a whole new bunch of science, new science results, which will reshape our view on life in universe, about origins of universe. Thank you.
For me, I originally came from the space station program, so I devote myself to the more than 25 years in the space program. So most of the impression was at completion of the space station in 2012. Yeah.
What excites me most is to think that our children will listen to the daily news and get every day a new discovery from living on Mars.
Great. So I want first to thank the audience, because you have been so active, and we are really sorry we could not answer all the questions which you have asked. But it really shows that you are interested, and it also shows, the young generation will be really a part, of this new space exploration era. Please let us applaud my distinguished panel.